Okay, so vector and parametric equations in two space. So the vector equation, okay, so this is a vector equation in two space specifically. We write it as vector r is equal to a point on the line plus a parameter multiplied by the direction vector. Okay? So they have a whole explanation here, and they go into how we can create this equation. What we're going to do is we're going to draw out a vector in two space, and then we're going to write it in our vector equation form. Okay, so we can see the difference between it. So let's say we have a vector here. Kind of make up, actually we'll make up some coordinates for it to make it a little easier for us. Let's say point A is at -6 and 2, and point B will be at 1 and 8. Okay, so we're going to plot these points, -6 and 2, and 1 and 8. So we have our vector AB. Now we want to write this as a vector equation. The first thing we'll need to do is get a position vector for it. Okay, so our positional vector, we're going to have to subtract our values to find a positional vector. That is a vector coming from the origin going in the same direction. Now looking at this, it looks like we're going to have some type of positional vector like this. Okay, so we're going to get the actual coordinates by subtracting our points. So very similar to when you guys were working with grade 9 slope y-intercept. We're going to call this x1 and y1, x2 and y2. To find our positional vector, we're going to take x2 and subtract it from x1. And to find the y-coordinate of it, we're going to take, that should be a 2, y2, subtract it from y1. Okay. So in this case, x2 being 1, x1 being -1, so we're going to subtract, -6. y2 being 8, subtract y1 being 2. Our positional vector will become 7 and 6. So that means we're going to be going from the origin to the point 7 and 6. This is our positional vector. Put it in red. And we can call this OP, which is what the book will usually call it, here being our origin, P being our point, our new positional vector, OP. Now to write it as a vector equation, okay, we'll say our vector r is equal to any point on the line. So there are two ways right now we can write this, and there are actually many more. We have two coordinates on this line. We have A or B. So I can decide to write this as -6, 2, plus, we have to have a scalar multiple for our parameter. Okay, and usually in the textbook they use the letter T. So they'll say T multiplied by our directional vector. Now this is the one that has to be the same all the way through. 7, 6. So this is a vector form of equation. So it's a vector equation. We can rewrite this a couple different ways. First of all, we can use the same directional vector with just a different point on the line, being point B we know is at 1 and 8. So this is acceptable. Same parameter, we'll use T, and the directional vector, 7 and 6. This is still the same vector equation. And we could also, and I'm going to use just a different parameter so we don't get confused, we can put any scalar multiple of this directional vector. Now on our graph, I can't actually fit an easy scalar multiple. I could double these numbers, let's say. Using the same points, we'll use the original one again. -6 and 2. We'll use a new parameter, S. It's still the same vector equation, and I'm just going to double our directional vector, 14 and 12. It's still in the same direction. It's just a scalar multiple of the other one, and it's still going through these same points. So these are all equivalent vectors. They can just be written in many different ways. Okay, so let's stop. Okay, so those are the vector equations. We're going to link them to parametric equations, okay? The parametric equation, the easiest way to set it up is to actually rewrite it as a vector equation by just replacing our symbol for the vector with an x and a y when we're in 2 space. If we go to 3 space, it'll change a little. So normally where we would write vector r, we're going to write two coordinates x and y. Okay, is equal to, we'll use the original vector equation that we wrote, passing through the point -6 and 2, plus the parameter of t, and directional vector 7, 6. A parametric equation is written as x is equal to a coordinate, so usually written as x naught, plus the parameter of the x value, which is usually written as a, and y is equal to y naught plus the parameter of b. Looks confusing, but an easy way to set this up, okay, is we're just going to link our x is equal to our coordinate and our directional vector times the parameter. So for x, we have x is equal to, we used the first two, -6, which is our x naught, and 7 times t will give us 7t. So here's our parametric equation. And the same idea goes for y. Y, we use equals again, our coordinate and a parameter times our directional vector. So y is equal to 2 plus 6t. Okay? And what's good about this form is we can find coordinates along this vector very simply when we're in our parametric form. Okay, so let's write that title there. And what we mean by that is I can put in any multiple or any number for our parameter t and find xy coordinates along this vector. So let's say we want the parameter of t when it is equal to the value of 3. We plug it into our parametric form to find out what our x value would be. So x is equal to -6 plus 7 multiplied by our parameter 3. Okay. Which means we're going to be left with x is equal to -6 plus 21. X equals 15. So this is a coordinate along our vector. This is an x value. And for our y value, we use the same equation, 2 plus 6, multiplied by the same parameter of 3. Y is equal to 2 plus 18. Y equals 20. So one of the coordinates along this vector is 15 and 20. And with that being said, we can do the opposite when we're in our parametric form. We can verify if coordinates are along the vector. So let's just make up some values here. Whoops, wrong way. I'm going to wonder if this point, we'll call it point Q. I want to know if the point 52 and 65 are on this vector. So a simple way to do it is once in parametric form, we'll rewrite our two parametric forms here. X equals -6 plus 7t. And y equals, oops, I lost it, 2 plus 6t. Okay. Once in this form, we're going to use these values here, this being our x coordinate, to replace x, and this being our y coordinate to replace y. In order for this to be on that vector, our parameter t must be equal in both situations. So we are going to find a value of t. If they're not equal, that means this is not a coordinate on this specific vector. So let's plug these values in and find out. 52 is equal to -6 plus 7t. And 65 is equal to 2 plus 6t. We're going to solve for t in both equations. We bring the 6 over. That gives us 58 plus 7t. Whoops, not plus. 58 is equal to 7t, which means our parameter is 58 over 7. And our other equation, we bring our 2 over. We're left with 63 is equal to 6t. Our parameter for t is 63 over 6. Highly doubt these are the same numbers. Quite sure they're not. But let's double check. 68. But 58 divided 7 gives us 8.2. And 63 divide 6, 10.5. So the parameters were different in this question, which means this point that we just randomly made up does not lie on this vector. And those are two of the ways parametric form can be very helpful compared to our vector form.